Hello and welcome to Amvic ICF Installer Training Session. My name is Marty McCartney and I'm the Technical Training Manager here at Amvic. I've had over 40 years of construction experience. In the last couple of decades, I've worked with the ICF products. One of my goals is to try and shorten the learning curve of people working with ICF in order to make their experience a much better experience. Today we're going to talk about many things, so I'll give you a bit of an overview. We'll do an introduction of the products, tools, accessories, and materials, footings and slabs, installation process, reinforcement situations, window and doors, alignment and bracing systems, penetrations through the ICF walls, concrete placement, floor systems, moisture protection on the exterior, interior, exterior finishing, some special applications such as short corners, etc. And then we'll show some photos of some Amvic ICF projects just to tidy it up. Introductions. With our product, it's actually a stay-in-place form made of EPS products and the polypropylene webs. You get your structure basically from the concrete, the insulation value from the EPS on each panel, a sound attenuation, you get a vapor barrier, air barrier, and then you get the webs to fasten internally and externally. ICF features: fire resistance, a 3-hour plus fire rating on our product, apparent sound transmission class 47 plus, thermal resistance. We have two different products. We have an R22 product and we have an R30 product. When it comes to holding to these webs, we have a 198-pound pull-out strength when using a coarse threaded screw. We have one of the strongest factory assembled ICF with a fill rate capacity test with results of 165 pounds per square feet. Foam panels density is 1.5 pounds per cubic foot. And we have a fully reversible block with our patented form lock interlocking system, which has a full 1-inch depth. R22 ICF is available in 4-inch, 6-inch, 8-inch, 10-inch, and 12-inch core sizes. The R30 forms are available in a 6-inch core and an 8-inch core. Typically, we have 45-degree corners, 90-degree corners, tapertops, brick ledge forms, and T-blocks. We can do factory cut radiuses when given the proper information. Brick ledge extensions are available for forms that we don't already have a brick ledge, and factory cut height adjusters to enable any height required on the job site. We also have accessories, and plumb wall bracing is available through Amvic. 45-degree block, straight form, 90-degree form. Just to give you some illustrations, a double tabletop form. The T-block, we have a long and short version, which allows for the offset running bond when you as you go up through the build, and then our brick ledge form. We can also do the radius. As mentioned, you give us the actual radius of the walls in hand, and we can pre-cut it in the factory. It'll come flat shipped, and we'll create the radius on site. There's a quick idea on the brick ledges on the bottom left. We only have straight forms, so it means you have to miter cut those corners. And then there's a picture of a radius wall, just to give you an example. We can supply double-sided factory fabricated height adjusters, and then you can also on-site cut to various different heights. And there's some examples on this slide as to how to cut them in order to get the interlock. When it's cut on site, you actually only get interlock on one side, so it's usually applied to the bottom or the top of the wall. We have an innovative web design, 100% post-industrial recycled polypropylene webs. They're spaced at 6-inch centers on our R22 form and 8-inch centers on our R30 form. Our blocks are fully reversible. The webs will hold the rebar in place for contact splices or a non-contact splice, which I'll get into later when we get into the reinforcing section. And it allows for the blocks to be cut in half and to use the forms from either side. With all this taken into effect, we can actually get our waste factors down to about 1%. Many different construction applications. When it comes to using ICF, we can do residential, commercial, institutional, industrial, or agricultural buildings. Building additions or retrofitting, crawl spaces underneath front porches, for instance. Exterior retaining walls and swimming pools have become very common. Single-story or high-rise buildings, multifamily, institutional, healthcare, retail buildings, or warehousing. They're all easily done with using ICF products. With these buildings, we end up with a sustainable, resilient, and environmentally friendly building. Here's a couple pictures of some modern examples. Multi-story buildings. Just to give you some ideas, Lawn Care Jury End happens to be a hotel chain that we do quite a bit of work with. First responders, very, very important to have a structurally sound building that hurricane areas and what have you especially, and then educational buildings. Agricultural buildings, what we found with them is it tends to be very easily climate controlled completely using the ICF walls, so it gives them a much better ability to control that, how that building performs. Certifications and evaluations. Amvic has gone through the process of being certified with the CCMC, Canadian Construction Materials Center. On the Canadian side, the ICC, which is basically the American affiliate, and then we have the QAI, which for our quality control assurances. When it comes to testing, I'm showing a list of testings here. We have a lot of testing on our webpage, testing results on our webpage, which can be brought up, and we can help people get through whatever it is they need for their specifications or to validate what they may need for building officials. And just another example of some of the list of testing, such as smoke density, etc., burn rates. We have all that available to help and make sure that people get the information required. Tools, accessories, and materials. Basically, on a job site, you're going to need some hand pruning saws or rip saws, portable power saws, keyhole saw, table saw. Most of the stuff that guys are going to have that are already contractors. Hammer drill for working with concrete, framing squares, obviously for layout, etc. One of the most common tools nowadays tends to be a laser. A lot of stuff is done with laser levels to make sure that we're starting from plumb and straight walls. Chalk lines, snap the footings, steel benders for cutting and bending rebar, scaffold planks to walk on, and the ICF bracing. Reinforcement steel, you're going to need to pre-organize that. I always joke about ladders. What tends to happen is we build up in the basement, we get excited about stacking block, and then we realize we don't have a ladder to get back out of the building, and somebody's got to crawl over the wall. Screws for bracing, concrete screws, lumber, plywood, and other types of bucking materials, wire ties, zip ties, sleeves for any protrusions through the walls for mechanical or electricals. You get OSB or plywood for cut joints, and you get your waterproofing and damp proofing systems. For concrete pour, you're going to need a concrete vibrator, rubber gloves, more of the safety side of things, hard hats, finishing tools, and flat shovels. And then when it comes to actually working with the ICF, you're going to need a hot knife or electric chainsaws for cutting and grooving for electric wires. And then when you make mistakes with stuff with that, you can do spray foam gun and spray it with foam to fix up your issues. Footings and slabs. We basically build on either footings and a 4-foot frost wall, or we build with a slab. So there's a dowel placement showing on this one. And there's a slab on grade, again, showing the dowels, which will be the center of the walls as you go to build your foundation. Some good descriptions here on how types of footings. Slab on grade. ICF can provide a slab edge, so you can go down over the front edge as per that first illustration. It gives you a hard surface to work on, nice flat surface to work on. It's a sturdy way to build on a job site. Very efficient because you're already clean, you're not working in the mud, and you're ready to go. On the regular footing, you could provide great design flexibility for depth, size, and direction when needed for frost walls. So anytime you have the frost wall requirement, you'll end up with a footing and then a frost wall. It's the most common that we use here in our area. When it comes to dowel placement, people ask me all the time, where should I put the dowel? And I jokingly say, put it in the middle of the wall. The truth of the matter is there is a different ways depending on our R30 or our R22 form, how we can start to lay that out. If somebody really needs to get at that, I could read through this, but at the same time, it could change based on your product. So we do have a guide that would help that. And then when it comes to level surface, we must make it within a ½ inch. You want it square, and that way the design project or the project starts off very well. Installation process. We started by outlining the project on either the slab or the footings. And what I like to do is snap a line, and some people will put a steel angle or a C-channel down in order to lay their block into or to push it up against. There's no right or wrong way of doing that. It's whatever you prefer based on what makes you most comfortable when you're doing it. It just gives you a nice straight edge to work with, especially for the long walls. Then we'll mark out the center of the windows and doors. One of the things that happens is if you do that preliminary layout, you can get your centers of your doors and windows, and that way you kind of measure it out once, mark it on your footings, and then we give a cut line, which usually is the bottom of the opening, and it just makes sure that people, as they start to stack block, they remember where the cut lines are and where the windows and doors open. We'll start out by ordering some rebar from the supplier. Most residential situations, you'll end up with your 20-foot long bars, whether it's 10 M or 15 M bars, and then we'll cut and bend on site. If it's a commercial job, we quite often do what's called a cut list, and it goes and gets prefabricated and brought to the site as a package. Then we move all the tools inside the building, try and make it, and equipment, so try and make it easier to work with. And one of the things I tell people is once you've done your layout and you've done your measuring, you can now load the job site. Keeping 6 feet away from the inside of the wall lets you put your braces and stuff up easily later, but you get everything down in there so you're working from the center of the building around the perimeter. And the next thing we do is you determine the height of the wall. It's very important to double check where your wall heights have to hit so that you can do any pre-cutting before you start, or whether you need adjusters to make sure you're going to hit the right number. When starting the first course of block, you're going to want to determine the height of the first row. It's very important to make sure that you're going to hit your wall height. Set your corner forms and then lay blocks towards the center of the wall. If you zip tie the vertical joints, it'll make sure things are tight, so when you cut that last block, it'll fit properly. Once everything is on line, measured, set up, then you can lay your rebar in to get ready for the next lap. When you get to the second course of the block, you're going to place the corners the opposite direction. We have corners that have a long tail and a short tail, and we just offset them to create the running bond. Stack the forms towards the center of the wall again. Cut the filler in the same area as the first block to minimize the offsetting of the webs. Tie down the forms to the first row. What we like to do is tie the first 2 rows together to get a good connection, the top 2 rows and the corners, and that way we get the whole wall tied together. And then install your horizontal rebar again. Here's an example of what it looks like to have a footprint laid out, 2 rows high, everything's working, everything's fit, you're on your lines, and then you're ready to carry on with your project. After the 2 rows is when I like to stop and check for level, and then what we'll end up doing is whether we have to cut or shim. It's easily done at that stage when the wall is not full of much rebar, and you can adjust as required. When that's all done, you double check your level, make sure everything's good, footprint's good, ensure that all the lines are set. Then we use low expansion foam to adhere the forms down to the footing. If you've cut the nubs off, we like to use a continuous bead to make sure we get a good connection. And if we have that space below there, what I like to do is about every foot or so, you do about 10 or 12 inch spray, and that just makes sure these forms get secured down to the footing. Allow it to set, usually about an hour, and then you can carry on building your walls. Subsequent courses, you're going to start at the corners again, always from the corners, work to the center of the walls, and then make sure your horizontal rebar is in. When you get to the top course, you're going to want to tie those blocks down to the one below just to make sure it's secure. And then you're going to install your vertical rebar as per specifications. If you're going to pour above this level, you're going to want to protect those interlock from getting filled with concrete. Makes it a lot easier to carry on up with your build. Reinforcement. All kinds of considerations when you look at reinforcement. Wind load, seismic, soil conditions, all these, height of wall, height of backfill against the wall, type of backfill, length of walls, width and openings in the walls. All these items pertain to what the rebar reinforcement will be required. Rebar placement. Different guides to use as per structural engineer design. So if the building has been designed by the engineer, you're going to want to follow their recommendations and make sure that he or she would cover off inspection wise. There's also prescriptive code, which is part of the building code system, and usually it's a building official would look after that, as you would have a building official look at the Amvic ICF guide. If it's been used and been approved prior to build, then that would also be covered off. In many locations, rebar placement needs to be inspected by a building official prior to concrete pour. And I think in most cases it has to be inspected, whether it's by a building official or by the engineer of record. We have an Amvic ICF design guide, Canadian and American version, that we can help people get their lintels straightened out, their wall reinforcement. It's a very good tool to help with construction and with the engineers and or the architects to get things properly reinforced. Lap splices. There's two different types of splices. It's anytime you have rebar overlapping, anytime you have rebar in the wall, it has to be overlapping. So whether it's a contact splice where it actually touches each other, or whether it's a non-contact splice where it runs past, there's a formula. So first of all, it's 40 times the diameter of the rebar for lap splice, and then you can have an offset of up to a maximum of 6 inches based on 1/5 the length of the actual overlap. When it comes to horizontal reinforcement inside these ICF walls, the webs are specifically designed to hold the rebar in place without having to tie with a contact splice joint. On the first course, you're going to want to come below grade. You're going to want to have the rebar holder that's closest to the inside of the wall will carry your horizontal rebar. On the second course, the next notch out will then have a rebar as illustrated in this photo. And then you repeat that pattern back and forth so that when you get to the top of wall and then you go to place in your vertical rebar, it's held in place by those horizontal bars in the inside third of the wall to make sure it's structurally set up to do what its purpose. There's a quick example looking down through where you can see it go back and forth, and then the vertical rebar would be placed in there and held in place inside that cavity. Vertical reinforcement. It's placed after the wall has been stacked to the desired height. You slide it in place from the top and weave it in between the horizontal bars that we've set in place. For multiple floor buildings, cold joint connections are required as per project specifications. What's going to happen is you'll have to decide how you do that, and it's usually a wet set process whereby you'd pour the concrete and then insert the cold joint connections. Okay, windows and doors. When it comes to windows and doors in the ICF walls, you're going to need a bucking system to hold back the concrete to create the void for the window or the door. Wood bucks tend to be the most common used, and when you go to use wood bucks, you're going to want to determine the size, the type of wood, whether it's pressure treated or not. You'll start by figuring out the rough opening sizes. And when you build your bucks, you're going to want to make sure the sides and the top are full width based on the form size. And the bottom needs to have an opening in it to allow for pouring concrete and then vibration. Here's a couple examples of some window bucks. The one on the left is a OSB with 2x4s, again, open in the bottom and able to work with that concrete that has to get in the bottom of the window. And the one beside that is a 2x6 on this particular case inside the core of the wall and just simply stops it. Both these will have to be reinforced. Curved bucks. Bucks can be designed to virtually any size or shape, so a lot of times we pre-build them for the opening, put them in place, and then we cut the EPS around it to make sure it's going to form to it. Here's some examples again, buck installations. You want to cut the foam about a 1/4 inch big just to allow for squaring up the buck properly, and then you're going to install your rebar around the opening as per specifications. When you go to prepare these bucks for concrete pour, concrete, basically a cubic meter concrete weighs approximately 5,000 pounds, so you want to make sure you got some support there. You're going to do cross bracing, and this is all temporary bracing that would come out after you're finished. Again, they can be any sizes or shapes. There's an elliptical, there's a round one here. It just gives you lots of different examples that any kind of opening you want to put in your wall is easily bucked out to make sure your windows or doors are going to fit properly. You can also purchase vinyl bucks pre-made. That's quite common in custom homes, especially that we see the top left where it's a circle, so a round window. And then you can also get vinyl bucks that are squared, reinforced. Again, you're still going to have to support these for temporary shoring. And then there's just a couple pictures of how the bottom opening is, along with the guy working on securing the bucks in the wall. Alignment and bracing. When it comes to bracing ICF walls, we want to make sure that we have total control to provide a straight plumb wall when we're finished. Normally what we do after the 3rd or 4th course is stacked, we'll install the braces on the inside. That reduces the amount of travel we have to do around the building. We'll start within the 2 feet of the corner, and then we'll work in increments of 6 feet to stay within the OSHA rules. We'll supply extra bracing at the corners of the windows and doors, and we'll have a couple extra braces anytime there's a T-block involved. This is one type of bracing possible. It's a lot of work, a lot of labor, a lot of expensive wood that tends to be not reusable. You might be able to use some in back framing, what have you, but doesn't give you very much control of the walls. This is more what we're looking for. Bracing systems allow for strong backs up against the wall, angle supports back out to the ground, adjustability on the angle brace to give you inward-outward movement to align your walls. Another illustration of bracing around the inside of the wall, just to give you an example of short corner braces, extra braces added, nice clean, easy to walk on, creates the planks, very easy to work with, and they're reusable from job site to job site, so you get your use out of them. Here's a plumb wall, tall wall system for the extra tall walls, kind of a ladder system, multiple layers to platform, multiple layers of platform to work off of, and then you have your outriggers. This one here, we used actually a scaffolding system. As we went up the wall, we just added scaffolding and moved our actual adjustable braces up, and we're able to work off the platforms from them and then tie down to the platforms on top of the scaffolding. This just shows a brace extension. So sometimes when you have a 4-foot frost wall down below the wall and you don't want to pour it separately, you can put the braces at the same level as the main wall, extend your braces down to the connecting to the floor, and make sure you got support. Additional support bracing required when you have things like a standing seam, as of the top picture, or an offset seam that's too close. So anytime we have a vertical seam within a few inches of each other, we'll put some extra brace in there to make sure we pour concrete that's going to hold in place. When in doubt, brace. Number one complaint in this industry tends to be crooked walls. So when you use engineered bracing with turnbuckles for alignment, you can minimize the amount of issues you have afterwards. It gives you a lot of ability to adjust those walls and make sure you're plumb and straight. These particular braces also work as a platform, so you get that built into the system. Penetrations. Anytime you're building a building, you're going to have stuff go through the wall. Services, electrical, sewer, water supply, natural gas, HVAC system components. One of the ones I always forget is dryer vents. Never think about it until the last minute and then realize we're going to put a dryer vent out through a concrete wall, so we better make sure we get that accommodated. Any exterior electrical fixtures, low voltage wiring for internet or cables for speakers, that kind of thing. Any wall chimney vents, if you're putting a gas fireplace in or whatever, you want to make sure. And then any just vents, such as a kitchen exhaust vent, needs to go through these walls. So what we tend to do is, after the wall is stacked before the concrete's poured, we'll cut through and put EPS, or we'll cut through the EPS and put either an ABS or a PVC pipe through, and then we'll spray foam around it. It's a temporary pass-through that would be pulled out after the concrete's poured to allow the actual item to go through the wall. And then consider anything in addition to for the future. If you want to add speakers to a deck later or something, you can always put a couple extra penetrations through to make sure it's covered off. Beam pockets. Basically, it's a type of penetration through the wall, but you want to make sure that it's there before you pour your concrete so that you're not trying to cut it out with a quick cut saw or jackhammer later. And really all you're doing is just you're trying to block out the void between the openings to make sure that the beam would fit back in place afterwards. We tend to use foam or a wood buck, very similar to a window buck, and just create that void so that when the concrete's poured and you pull that out, it creates that the ability to put a steel beam in there. When it comes to concrete placement, number one, safety. Safety precautions. Wear your hard hats, protect your skin, whether it's gloves, long sleeves, long pants, and then of course, most important, goggles and safety glasses to cover protecting your eyes. We have different mixes available. Most concrete supply places now have an ICF mix when you talk to them, and it'll be a specific mix. It's usually a 20 or 25 MPa, and quite often you use a P-stone. So here's the recommendations. It's a chart that we can supply to make sure that you're being covered off and using the proper mix when you go to pour your walls. One of the most important things about it is this recommended 3 to 4 feet per hour. When it comes to safety, you're not supposed to pour concrete more than 4 feet per hour. So if you stay within that and something ever happens, you're fine. And you just make sure the job site goes well and safe. Different ways to pour some concrete in the walls. Concrete boom truck's probably the most common nowadays. Conveyor belts are still used where it can be reached. The chutes on the back of the mixers isn't used very often because a lot of places now you are not allowed to come within a certain distance of an excavation, so the chutes don't reach. And then years ago, when I first started, we used to use crane and buckets. And it's a very archaic system whereby you have about a 3/4 meter of concrete being released at a given time out of a bucket that is put up with a crane, and it can be very very dangerous to work that way. But so most common, concrete boom trucks. When it comes to the size of the crew, minimum of 4. We can stack walls with 2, 3 people, no problem. But when it comes to pouring the walls, we want to have at least 4 people on hand, just for the sake of the fact you're dealing with the concrete. And you always start the pour approximately 2 feet away from a corner, then work around the wall and doing a circular motion. So you just keep going around and around and try and stay to that 3-4 feet per hour. When it comes to the 90-degree corner specifically, avoid pouring directly into the corner. If you start 2 or 3 feet away, let the concrete flow into the corner, and then you jump to the other side of that and let it flow back in, you minimize the amount of pressure that's actually on that form in the corner. And then, of course, ensure proper concrete consolidation. pouring around the windows and door bucks. You're going to fill the buck opening in the bottom, and then you're going to fill up both sides so that it comes up just slightly past the opening in the bottom. What that tends to do is by the time you come around the next round, it has held and will not facilitate the concrete coming up through your center hole that's in your buck. So it's just an easy way to make sure that the wall gets filled properly, and then you're going to vibrate between each layer, obviously, to make sure you have proper consolidation. One of the things I like to do is when I have a lintel above, we'll put a piece of wood across to make sure that when we scoot our hose going laterally across the top of a wall, we don't get remnants of concrete in that cavity as we go around each time, which causes poor consolidation at the end. This way we take the piece of wood off in the last run. It's a nice clean cavity and it's full of fresh concrete. And then again, of course, proper consolidation is the key when it comes to pouring concrete in these ICF walls. Consolidation. Consolidation eliminates pockets, honeycombing, and trapped air, allowing it to mold around the rebar and embedments. It's internally consolidated, mechanical vibrators used, usually a pencil vibrator. And there are systems out there that have external vibration, which are basically a plate on each side, and there's a frequency sent through to create the vibration. Most common in our areas is the mechanical vibrator, and we suggest using a pencil vibrator of up to 1.25 inches. So immediately after each concrete pour lift, you're going to want to completely immerse the vibrator head down into that concrete. If you're going into a layer below, you want to make sure that those two layers get consolidated together. You hold it from 5 to 15 seconds, and then you just pull it up, and then you move from laterally along the wall and repeat that same process. You're going to move the vibrator and insert it in a distance of 1.5 times the radius of action. There's a chart to the right here that kind of helps with that description. And what we find is basically every second cavity works best. Penetrate 6 inches into the previous layer just to make sure you're getting that proper bond. And then as you pour each lift, you want to go down through to the one before, especially since a certain amount of time, probably about an hour has gone by, you want to make sure that gets consolidated. When the surface gets kind of shiny, it'll talk to you. It'll let you know what's going on. So stop when the surface becomes shiny and move over to the next. When it comes to finishing the pour, if the second floor is going to be poured above, you want to stop with concrete lower than the top of wall to make sure that you're going to get a keyway back into that wall. It'll help tie everything together. If it's the final course of the block, when you go to pour, you want to trowel the concrete off with a laser, and then make sure you wet set your anchor bolts that's going to carry your top plate. After the pour, immediately after the pour, check your corners for plumbness and your walls for straightness. Using the bracing alignment systems, you're going to want to make sure you line up to your string. If you have to pull the wall inward, it is best to put a brace on the exterior and push it back in. What happens is we are only screwed to the walls through the webs with a small, usually a number 10 screw, so a lot of times you won't have the strength in that wall to pull it back in without breaking loose. And then, of course, the biggest thing is clean up your braces. Your platforms, while the concrete's still wet, it's just a lot easier to do that cleanup. When it comes to blowouts on ICF walls, one of the things I tell my guys is we'll talk about blowups, we'll get a blowout kit ready, we'll get a few pieces of OSB or plywood, we'll get some 2x4s, we'll get some screws, we'll get make sure the chargers, the screw guns are charged up, we'll have a ladder, and then we'll have this conversation and nothing will happen. On the days that we don't have this conversation is usually when something will happen. Flooring systems. With a reinforced concrete wall system, many flooring options are possible. Here on the right is a picture of a couple of substantial flooring systems, such as the hollow core planks or the Hambro system. Flooring systems can be made of wood, metal, concrete, or a combination of all three of these. The ICF construction at a floor intersection is contingent to the flooring system. Those details would need to be provided to make sure you have a secure system. For residential applications, the selected floor system is chosen for simplicity and cost effectiveness, which is usually a wood floor system and a ledger Ledger installation with anchor bolts. Traditionally, ledgers were installed by using anchor bolts, and there's a whole process listed here on the next couple of slides. But nowadays, what tends to be the norm is the Simpson-Strong-Tie ICF VL system. Simpson-Strong-Tie provides charts to make sure that you're using the proper spacing in order to get what you need to facilitate the construction of your project. What happens is the ICF VL bracket gets inserted into the wall prior to the pouring of the concrete. After the wall is poured, you will laser install your ledger with the J brackets, and then you'll hang your floor joists off the top mount brackets on that ledger. Another example, open web joists, same system, Simpson-Strong-Tie in the wall, J bracket holding the ledger in place, the joist gets fastened to that ledger. Here's a metal floor system, same principle. It can still get fastened with the ledgers. As we move farther and farther into the future, I think steel studding, steel frames, steel wood or steel floors are all going to be part of normal construction. And we see a lot more hollow core being used even on residential situations, such as garages especially. And then we have a T system here, which creates a roof plus the joist system all in one for large, long spans. And then we have a proprietary Amdex system, which we'll get into more detail later. Moisture protection. Moisture protection is required by building code, and there's two different types. There's waterproofing and damp proofing. Basically, the difference is the waterproofing resists the hydrostatic pressure, and when in doubt, you should always install the waterproofing. There's different types. Here's a membrane, self-adhesive peel and stick. It adheres to the walls. In most cases, you'll need to use a primer. And then there's a liquid process where you can paint them on with a trowel, roller, or brush, or a spray system. And you must make sure that these products are compatible with the ICF walls. And on top of this, they quite often will put a dimple facing inward to create an air gap. Here's a picture of Suprema, for instance, attached to the outside of the wall, waterproofing membrane. There's a couple other pictures just showing coming up above grade, rough grade actually, and then taped off to hold it in place. And you can actually see the dimple board on the right-hand side at the grade level. When it comes to foundation drainage, it's basically required on all below grade walls, and it's on the outside. It goes down below the footing to make sure it's protected. When it comes to dealing with the transition at the grade level, there's various ways of doing it, and this slide shows you the different options. Interior and exterior finishes. The most common used finish on the inside of the walls is drywall, and it can be fastened directly to the webs. You can also use wood paneling or a thin veneer stone, such as tiles. They all work well. Electrical and plumbing. Location of electrical boxes marked and cut out. Use the electric chainsaw or hot knife to cut the groove for the electrical wire to follow along the walls. You push the wire in a groove, and then you make sure that you use a single wire per groove. And you feed your wire into the box. When you attach the electrical boxes to the webs using a side mount flange box, it's the most common. It gets screwed into the side of the web. And then the R22 requires a shallow box, and the R30 you can use the regular depth boxes. When it comes to the plumbing, you just cut out wherever you need to put a pipe. Most times the exterior walls do not have water lines run in it, so it's not a very common situation. Here's an example of a hot knife used with an attachment to cut out the actual electrical boxes. Exterior finishes. On the exterior, there's all kinds of options. Siding, whether it's wood, vinyl, or composite. In most cases, it requires strapping, so you need to conform to the manufacturer's specifications. A stucco system, traditionally, it can be applied directly to the EPS. Sometimes you may need a drainage layer, and whether or not you use masonry, which you have to make sure you have your air gap and a brick ledge to supply the support for such. Special applications. In this section, I'm going to try and cover off short corners, gable roofs, radius walls, and then floor systems such as Hambro or the precast, steel joists, or the Amdeck systems. Quite often you end up with a short corner less than 14 inches, and if you use 2 straight blocks, cut them where they need to, overlap them, cut them to where they need to be, fill in the gaps. Then we use some conventional framing such as these 2x8s here, create a forming support, drill through and anchor it together. You end up with an ICF wall with a non-manufactured corner, and it's strong as ever. When it comes to gable roofs, quite often nowadays we build them on the ground, put it up in sections, then pour it at the end. That way it's a lot safer. Quite often you want to look at it and see whether or not they really need to go all the way up, so you determine your heights. Radius walls, this is an example of inside of the radius here and then another outside on the right hand side, just to give you an illustration of how that works together, integrates back into the wall. Hambro floor system is basically a steel girder system that uses temporary plywood forming. You put your reinforcing and your concrete. Precast slabs come pre-made, and then you'll do a topping on it to make sure it's nice and level. Our Amdeck system, we have the ability to conform to various lengths, and we have the guides to help you with that. As it's a suspended slab, it will need to be engineered. Amdeck floor and roof system. We have the Amdeck Pro system, which tends to be used for the commercial sector. We have an Amdeck Eco system, which is meant for low-rise and residential projects. They're basically modular, lightweight forms, and they utilize a 10-inch steel channel or dimensional lumber. Typical spans are up to 30 feet, and they can be used with non-ICF walls if required. The Amdeck benefits: for roof applications, reinforced concrete can withstand tornadoes and hurricanes. These can be used for car garage floors. Thermal resistance of about R19, so you may have to augment that when you come to a ceiling situation. And then we have the sound attenuation. Amdeck Pro, here's a very good illustration of the different components and how it sits on top of the wall prior to pour, with the reinforcement included. The Amdeck Eco uses a 2x6 system, and then we have an 8, 10, and 12-inch height available. And then we have some projects here just to sort of finish off, to give you some ideas and things to look at. Open foundation, one with peel and stick and dimple board included. Some more, and then a finished one. I tell people on the bottom right that you can tell, the only way you can tell that's an actual ICF building is the fact that when you slam the front door, nothing in the house shakes. And we got gable ends here. One of the things with the gable ends, we used to spend a lot of time and form on both sides, and then have plywood ready. So you'd vibrate, you put the concrete in, you'd vibrate, you'd slap a piece of plywood in there and move on up. And the photo on the left, it shows we learned that we could use the webs as little dams. We'd vibrate the wall, we'd add a little extra concrete to the very top, let it sit for about an hour, and then go back in and screed that off, and it probably saved us 4 or 5 hours of 2 men framing that up to get it ready. Then we go back to commercial projects such as our beloved Tim Hortons. Some commercial strip malls, very big projects, go up relatively quickly using the forming system. Here's some multi and unit low-rise townhouse type systems. Multi-unit high-rise such as student residence, very common. They've been using ICF. Here's agricultural. This one happens to be a potato barn. And what they liked about this was it gives them full climate control inside of that building, which helps minimize the rot of their product. Hospitality industry, the hotel industry. And thank you. This is Marty again. We're going to open this up to some questions, and always know that the Amvic team is here to help you.